What if the greatest mind in human history was alive today? Not just alive, but fully plugged in. With a smartphone, a YouTube channel, access to ChatGPT, quantum computers, and the entire internet at his fingertips. I'm talking about Albert Einstein, the man who rewrote our understanding of space, time, energy, and gravity, using nothing but a pencil, paper, and a brain that operated on a completely different level than everyone around him. Here's what most people don't realize. Einstein didn't just discover things. He imagined things first. Then he proved them. He called it Gedanken experiment, thought experiments. He would sit in a chair, close his eyes, and mentally ride a beam of light. He imagined falling elevators. He visualized warped space. And from those images in his head, he derived equations that changed civilization. Now imagine giving that brain Google Scholar, a supercomputer, AI research assistants, live collaboration with every physicist on the planet, real-time data from the James Webb Space Telescope. What would Einstein.exe do if you ran it on 2026 hardware? Stay with me until the end, because this answer doesn't just change how you see Einstein. It changes how you see the future of science itself. Before we run Einstein.exe, we need to understand the original program. And I promise, the real Einstein is far more interesting than what they taught you in school. Albert Einstein was born in 1879 in Ulm, Germany. And here's the first thing most people get wrong. He was not a child prodigy in the conventional sense. Yes, he was brilliant, but he failed the entrance exam to the Swiss Federal Polytechnic School in Zurich on his first attempt. He was rejected. He had to spend an extra year preparing before he got in. After graduating, he couldn't get an academic job. His professors thought he was too independent, too difficult. So he ended up working at a patent office in Bern, Switzerland, reviewing other people's inventions for a living. In 1905, from that patent office desk, Einstein published 4 papers that each individually could have won a Nobel Prize. Scientists call this his miracle year. He was 26 years old. He had no lab, no research team, no funding, just his mind, his evenings, and paper. Let me break down what he did, because these aren't just abstract science. These discoveries affect your life right now, today in 2026. First, the special theory of relativity. This is where E equals mc squared comes from. Energy equals mass times the speed of light squared. In plain English, a tiny amount of mass can be converted into an enormous amount of energy. This equation is the foundation of nuclear power and nuclear weapons. Every nuclear reactor on Earth exists because of that single equation. Second, the photoelectric effect. Einstein proved that light comes in discrete packets of energy, which he called photons. This discovery earned him the Nobel Prize. More importantly, every single solar panel, every digital camera, every smartphone camera sensor works on this exact principle. The technology in your pocket right now exists because Einstein understood how light interacts with electrons. Third, Brownian motion. He mathematically proved that atoms exist, at a time when many scientists still debated whether atoms were real or just mathematical concepts. He proved they were real. Fourth, the general theory of relativity, published in 1915. Einstein completely rewrote our understanding of gravity. Newton said gravity was a force. Einstein said no, gravity is the curvature of spacetime caused by mass. Massive objects literally bend the fabric of space and time around them. This sounds abstract, but here's how it affects your life. Your phone's GPS works because Einstein's equations are programmed into every satellite in orbit. Without applying general relativity corrections, your GPS would be off by about 11 kilometers every day. Every Uber, every Google Maps direction, every military missile guidance system depends on Einstein's theory of gravity. Without it, they all fail. But here's where it gets fascinating for our thought experiment. Einstein, despite being the greatest physicist of the 20th century, had very real limitations, and they were almost entirely due to the era he lived in. He had no computers. He did every calculation by hand. His notebooks are filled with thousands of pages of handwritten equations, many of which contain errors he had to find and correct manually. Some of his most important calculations took him years, not because the math was too hard for him, but because doing it by hand was physically and mentally exhausting. He had no internet. He couldn't collaborate in real time with physicists in Tokyo, Moscow, or Chicago. Letters took weeks. Conferences happened once a year. If a physicist in India had an idea that would help Einstein's work, Einstein might never hear about it. He had no experimental data on demand. Today, telescopes like James Webb send back terabytes of data about distant galaxies, black holes, and the early universe. Einstein was working largely in the dark, theorizing about things he couldn't directly observe. And perhaps most importantly, he lived before quantum computing. The very theory he helped create, quantum mechanics, he rejected in its full implications. He famously said, "God does not play dice." He was wrong, and he knew in his later years that he couldn't fully resolve it. So now the question becomes real. What happens when you take this brain, with all its extraordinary power and all these eliminated limitations, and plug it into 2026? Alright, Einstein.exe is loading. Let's walk through what happens step by step in the first 90 days. The first thing Einstein does is not what you might expect. He doesn't immediately start solving equations. He reads. In 1 week, using AI-assisted research tools, he consumes the equivalent of 100 years of physics papers. Everything published since his death in 1955. String theory, loop quantum gravity, the Standard Model, dark matter candidates, dark energy measurements, the Higgs boson conformation, gravitational wave detection by LIGO. He immediately identifies something that every physicist in 2026 already suspects but cannot solve: the fundamental incompatibility between general relativity and quantum mechanics. These are the two most successful theories in all of science, and they completely contradict each other at the deepest level. This is the biggest open problem in physics. It has been for 70 years. And Einstein, who spent the last 30 years of his life unsuccessfully searching for a unified field theory, immediately recognizes it as unfinished business. He looks at the problem with fresh eyes that no living physicist has, because he built one of those two theories himself. He understands general relativity not just mathematically, but intuitively, in a way nobody else ever has. Einstein opens a research profile. Within 48 hours, he receives collaboration requests from over 3,000 physicists worldwide. MIT, CERN, Caltech, the Perimeter Institute, Chinese Academy of Sciences, Indian Institute of Science. He does something no physicist would expect. He doesn't focus on the biggest institutions. He looks for the most interesting ideas regardless of where they come from. He finds a 29-year-old physicist in Lagos, Nigeria, working on an obscure reformulation of quantum field theory. Her mathematics is unconventional. Her approach is unusual. Every established physicist dismissed her work. Einstein immediately recognizes what she's doing and contacts her directly. Within 2 weeks, they are co-authoring a paper. Einstein's geometric intuition combined with her novel algebraic framework produces something that neither could have created alone. This is where things get truly extraordinary. Einstein begins working with AI research assistants, not as tools that do his thinking, but as partners that handle the computational work that previously took him years. Here's a concrete example. In his original work on general relativity, Einstein spent 3 years on the field equations, 10 equations that describe how mass curves spacetime. The mathematics was so complex that even after publishing, He found errors and had to issue corrections. Some of those calculations took him months each. In 2026, he sets up an AI system to run those same calculations. Takes 11 minutes. Einstein now uses the time he would have spent on computation for something only his brain can do. Intuition, conceptual leaps, the thought experiments that no algorithm can replicate. He begins running simulations on quantum gravity models, testing theoretical predictions against the James Webb Space Telescope data in real time. Every morning, new data arrives from the deepest reaches of the observable universe. Every afternoon, Einstein's theoretical models are refined against that data. This is like giving a master sculptor not just better chisels, but the ability to see the finished sculpture before he starts carving. 90 days after Einstein.exe boots up, he submits his first paper to Physical Review Letters. The title is deliberately understated: A Geometric Reconciliation of Quantum Field Theory and General Relativity. A Preliminary Framework. Preliminary. Einstein calls it preliminary. The paper is 47 pages long. It contains 6 new mathematical frameworks, 3 novel conceptual approaches to the measurement problem in quantum mechanics, and a specific, testable prediction about gravitational wave signatures that no existing model predicts. The physics community explodes. Not metaphorically. The paper is downloaded 4.2 million times in the first 72 hours. It crashes the AR-14 server, the main physics preprint server, twice. 3 Nobel Prize-winning physicists independently issue statements saying variations of the same thing. This could be the most important paper published since Einstein's original 1915 work. But let's zoom out, because Einstein working in physics is only one thread of what happens when you run Einstein.exe in 2026. The ripple effects go far beyond science. 6 weeks after arriving, Einstein starts a YouTube channel. He calls it Thought Experiments. The first video is 14 minutes long. He sits in a simple room in front of a whiteboard and explains special relativity using nothing but a flashlight and a moving train analogy. No graphics, no animation, no production value. Just Einstein, a whiteboard, and that voice. The video gets 40 million views in the first week. It becomes the most watched physics video in YouTube history within 30 days. Comments are flooded with messages from teenagers saying, "I finally understand this, and this made me want to become a physicist." Teachers start using the videos in classrooms across 140 countries. By month 6, the channel has 80 million subscribers. For reference, that's more than most major entertainment channels. Einstein is somehow a YouTube star. Here's where the economic implications become staggering. Einstein begins consulting with fusion energy companies, specifically the teams working on making nuclear fusion commercially viable. Fusion is the holy grail of clean energy. It's what powers the sun. If we could recreate it on Earth in a controlled way, we would have essentially unlimited clean energy forever. Scientists have been working on it for 70 years. The running joke has always been, fusion is 30 years away, and always will be. Einstein reviews the plasma confinement models that current fusion reactors use. Within 3 months, he proposes a modification to the magnetic field geometry based on a principle from his unified field work. It's a change that current physicists would never have considered, because it requires understanding the relationship between electromagnetism and spacetime curvature in a way only Einstein's new framework provides. A private fusion startup implements the modification. In controlled tests, their plasma confinement time increases by a factor of 8. This is not a small improvement. This is the breakthrough the field has been waiting for. Energy analysts begin recalculating their models for when commercial fusion power arrives. The previous consensus was 2045, maybe 2050. The new estimates range from 2031 to 2035. The implications are almost impossible to overstate. Unlimited clean energy means the end of fossil fuel dependency. It means desalinating ocean water cheaply enough to solve the global water crisis. It means powering vertical farms to feed 10 billion people. It means cheap enough electricity that charging an electric vehicle costs less than a cup of coffee. Einstein's unified framework, the reconciliation of general relativity and quantum mechanics, has a direct application that nobody anticipated: quantum error correction. Current quantum computers are incredibly powerful in theory, but in practice they make errors constantly. Quantum bits, called qubits, are fragile. They lose their quantum state, a process called decoherence, very easily. Correcting these errors currently requires enormous overhead. A quantum computer that could theoretically run 1,000 qubits might effectively only be using 50 or 100 reliable ones. Einstein's geometric framework, applied to quantum information theory, suggests a fundamentally new architecture for qubit design. Instead of fighting decoherence, his approach uses the curved spacetime geometry to make certain quantum states inherently more stable. 3 quantum computing companies immediately begin building prototype chips based on this architecture. Early results are extraordinary. Error rates drop by 2 orders of magnitude. What does this mean in practice? Quantum computers at this error rate could factor encryption keys that currently protect the entire world's banking system. They could simulate protein folding with enough accuracy to design new drugs from scratch in days instead of decades. They could optimize logistics networks, financial systems, and climate models in ways that are currently computationally impossible. The cybersecurity industry immediately goes into emergency mode. Every encryption standard that currently secures the internet needs to be replaced. This is called the post-quantum cryptography transition, and Einstein's work just made it urgent. But here's where I have to be honest with you, because this thought experiment isn't just about the wonders. There is a dark side to running Einstein.exe in 2026, and Einstein himself would be the first to acknowledge it. Albert Einstein spent the last decade of his life consumed by guilt. Not because he built the atomic bomb, he didn't, but because his equation E=mc², was the theoretical foundation that made it possible. And because in 1939, he signed a letter to President Roosevelt warning that Nazi Germany might be developing nuclear weapons, urging the United States to accelerate its own nuclear research. That letter directly led to the Manhattan Project, which led to Hiroshima and Nagasaki, which killed over 200,000 people in 2 days. Einstein said late in his life, "I made one great mistake in my life when I signed the letter to President Roosevelt recommending that atom bombs be made." Now imagine Einstein in 2026, developing a unified field theory and advances in quantum computing, surrounded by military contractors, government intelligence agencies, and weapons developers who are all watching his work very carefully. The same physics that could accelerate fusion energy could theoretically be weaponized. The same quantum computing breakthroughs that could cure diseases could break every encryption system protecting military, financial, and personal data worldwide. Einstein would know this. He would feel this weight immediately. And the question becomes, how does he navigate a world where his ideas, no matter how peacefully intended, will be immediately examined for military applications by multiple governments simultaneously? Here's something nobody talks about when imagining historical geniuses in the modern world. The sheer volume of information available in 2026 might be as much a curse as a blessing. Einstein's greatest strength was his ability to simplify, to cut through complexity and find the underlying principle. He once said, "If you can't explain it simply, you don't understand it well enough." In his time, the entire body of theoretical physics was knowable. A single person could read every major paper, attend every major conference, and maintain a complete picture of the field. In 2026, physics produces approximately 400,000 new papers per year. Even with AI assistants to filter and summarize, The landscape is so fragmented that no single human brain, not even Einstein's, can hold a complete picture. Fields have become so specialized that physicists in adjacent areas of the same department sometimes cannot fully understand each other's work. Einstein's approach was holistic, intuitive, and cross-disciplinary. The modern physics ecosystem might be fundamentally incompatible with how his mind worked best. And then there's social media, the relentless, 24-hour opinion machine. Einstein was a deeply private person who became a reluctant public figure. He was uncomfortable with his own fame. He found the constant attention exhausting and often counterproductive to his work. In 2026, every paper he publishes would instantly generate thousands of reactions, many from people with no physics background who are absolutely certain he's wrong. Every public statement would be clipped, decontextualized, and argued about endlessly. Science communicators would simplify his work in ways that would make him cringe. Conspiracy theorists would claim he's hiding anti-gravity technology. AI skeptics would argue his partnership with AI tools means his discoveries aren't really his. The man who said, "I never made one of my discoveries through the process of rational thinking," the man who worked through imagination and intuition, would be operating in an environment that rewards rapid hot takes and punishes slow, careful, deeply considered thought. Would Einstein thrive on the internet? Or would the internet be the thing that finally breaks him? We've run Einstein.exe. We've seen what he would build, what he would discover, and what he would struggle with. But the real lesson here isn't about Einstein at all. The real lesson is about what we're doing with the tools Einstein never had. Right now, in 2026, there are humans alive with cognitive abilities equivalent to Einstein's. Statistically, this is almost certain. The question is not whether Einstein-level minds exist. They do. The question is whether the conditions exist for them to flourish. Einstein's genius required a specific environment. Enough free time to think deeply, access to the foundational ideas of physics, exposure to a diverse range of intellectual problems, and freedom from economic desperation. He had these things barely and only by accident. How many Einstein-level minds right now are working in call centers because they couldn't afford university? How many are in countries where scientific infrastructure doesn't exist? How many gave up on physics because the academic job market is brutal and their families needed them to earn money? The internet, AI tools, open access journals, online universities, these are not just conveniences. They are potentially the mechanism by which the next Einstein gets discovered. Not born, discovered. Because the next revolution in physics, in energy, in medicine, it won't come from some inevitable march of scientific progress. It will come from a specific human mind, probably young, probably from somewhere unexpected, being given the conditions to think deeply about hard problems. Einstein.exe is already running somewhere. The question is whether we've built the hardware that lets it execute. So, we ran Einstein.exe on 2026 hardware. Here's what happened in summary. In 90 days, he published a framework that could reconcile general relativity and quantum mechanics, the biggest open problem in physics. He accelerated fusion energy development by potentially a decade. He contributed to a quantum computing breakthrough that forced a global rethink of cybersecurity. He got 80 million YouTube subscribers, and he worried deeply about what his discoveries would be used for. The tools of 2026 would have made Einstein more productive, but they wouldn't have made him Einstein. That was already there. The miracle was always the mind. And that's the question I want you to answer right now in the comments below, because I want to hear your thinking on this. If Einstein had today's technology, which discovery do you think would have the biggest impact on the world? Is it the unified field theory that could unlock new physics we can't even imagine yet? Is it the fusion energy breakthrough? Is it the quantum computing revolution? Comment below with unified, fusion, or quantum, and tell me why. I'm genuinely going to read every single one of these. And if this video made you think differently about history, about science, or about what human potential actually looks like, hit that subscribe button. Because in the next video on HistoryOS, we're rebooting someone even more mysterious. I'm telling you right now, that one is going to break your brain. See you next video. Stay curious.